The next few lessons we'll be looking at how to solve related rates problems. Before we do that, I want to give you a general overview of how to do these problems, and then we'll get into specific skills. So a related rates problem is something where you know one rate of change of a quantity, and you want to find another rate of change. So, for example, if you have a bird flying along and a person looking up at the bird, maybe you know the rate of change of how quickly the bird is traveling along the ground, and you want to know the rate of change of the distance from someone's eye to the bird itself. And for all of these problems, they follow the same basic steps. First, we're going to draw a diagram. We're going to label any constant values that aren't changing with their numbers, and any quantities that are changing with variables. That's this first step here. Then we're going to write an equation relating the variables whose rates you know and the ones whose rates you want to know. We're going to take the derivative of both sides with respect to time, and then we're going to use a knowns and unknowns table to solve for whatever it is the question is asking for. Today, in this lesson, we're just going to look at this very first step, drawing a diagram, and we'll look at the other ones in later lessons. So the key skill here is just visualizing whatever is going on in a problem. So we're just going to draw a diagram representing each situation below, and we're going to label anything that we are given. So a person is looking up at a bird flying in the sky. The bird is h meters above the ground, and the distance from the person's eye to the bird is b. So all we're doing is drawing this. So I want to imagine this situation. I've got my little person. And they are looking up, and there is a birdie. So here is the flying birdie. The bird is h meters above the ground, so we need some ground. I'll grab a nice green pen. Here's a ground. And they are h meters above it. So let's say this distance is h. The distance from the person's eye, so here's an eye, to the bird is b, right there. And there, we've labeled a diagram. That's all there is to it. We'll do more complicated things with it later on, but for now, that's all we need. So let's look at another problem that might be a little bit harder to interpret. So this is saying that a trough of water, and a trough is just like a tub of water. It's just like, rather than being a bowl, a little bowl, it's just sort of like an elongated bowl. So a trough of water for dogs to drink from is made from a cylinder that has been cut in half across the diameter of one end. The cut side of the half cylinder is up. The cylinder has a radius r and a length l. The top of the water in the trough is 8 inches from the top of the trough. So let's just visualize this one piece at a time. So the trough of water for dogs to drink from is made from a cylinder. So I'm just going to start by sketching a cylinder. Okay, it's kind of like that. That has been cut in half across the diameter of one end. Well, I know that a diameter is half a circle, so that's got to be something like this. And if it's cut in half, so that means it's just going to be sort of like cut down like this. So basically, I took a cylinder like a Coke can, and I just like shwink, cut it in half. Just like that. Okay, the cut side of the half cylinder is up. So if I cut it right here, that means that it's supposed to be more like this. In order to sort of we can kind of see like this trough right here would be something for the doggy to drink out of. So I'm going to redraw that. So it looks like this. So here's that cut end. Let's see, I could definitely do better perspective drawing on this. Let's try that again. That could be better. doesn't need to be precise, but it'd be good if it was a little bit better than that. Okay, so let's say we got a half circle there. There we go. That's looking better. Drawing troughs is hard. There. That's a more better trough. Okay, so this is the side we cut, so that's up. So there's going to be water filling this in to drink. The cylinder has a radius r, so we've cut it in half, so that means that this distance here is r, and a length L. Well, this is r, so that's not telling us any more information, so this distance right here must be the length L. The top of water in the trough, okay, so there's some water in here. Let's see, we can sort of see this coming down over here. Throw some water in there. This distance right here, from the top of the water to the top of the trough, this, it says, is h. And once again, I could make that clearer. It's good to take some care in drawing your diagrams. They help you out in the next step. So this distance right here is h, from the top of the water to the top of the trough. So all we're doing in this lesson is just figuring out how to draw it in a diagram. Use your art skills.